Assalamu alaikum warahmatullah. Guys, this is the third recorded lecture in which we are going to discuss about the soil mechanics unit 2. It is one of the most important chapter in which we are going to study about the relationships between weight and volumes of soil. So as it is clear from here, the name of the chapter or unit it is volume, weight and volume relationship. So I will give you just a brief overview for the assessment. It is not a detailed lecture. So I will try to cover this all the things in a very short video. So I will try make this video short. Okay, there are two terms. One is weight and the another one is uh, mass. There is a little bit confusion between these two things. So I will clarify it from the explanation. We have one is mass and the another one is weight. So what is weight? For example, there is a ball which is made of steel and its weight is, let's say, it is 50 kg and it is on the earth. Where it is on the earth. So the metals from which the ball is made, it is from the steel is made. So now on earth its wazn is how much weight is 50 kg. When I shifted this ball to the moon, so when I made its mass, so it is still how much 50 kg. It doesn't change because the weight is what, sorry, here the mass is of the matter from which it is made, so it is not change everywhere, it is always the same. So it is mass. No, the same ball, like there is another ball, its weight is how much, for example, 100 kg. 50 kg is weight and there is some gravitational pull, gravitational acceleration, you already know about this. So a gravitational acceleration g, it is on earth 9.81 meter per second square. So this is the gravitational pull. It is also called sometimes gravitational pulls or the attraction forces on each of the items on the earth. So on earth it is how much? It is about 9.8. So when the same ball we shift it through any medium to the moon, so now its weight is how much? It is reduced, for example, to 60 kg. Why it is reduced to 60 kg? Sorry, it is in Newton. Before it was 100 Newton and then it is reduced to 60 Newton. Why? Because the weight it is totally depend upon what gravitational acceleration force. So its mean mass is the property of material from which it is being made. Like steel, if its weight is 50, so it is 50 everywhere. While made, it is the mass, but in multiplication with gravitational forces. So its weights, the weight is totally depend upon the gravitational force. So here we can clarify mass. It is same everywhere. It doesn't depend upon the position, either it is on earth on a moon, so it is same everywhere. But weights, it's depend upon the position. What does mean by position? On earth the gravitational value is more, so if the gravitational value is more, the weight is more. So as we move up at height, the gravitational pull it is decreased. So when the gravitational forces decrease, the weight is also decreased. How it is decreased? So there is a relation between mass and weight. As we know, W is equal to weight is equal to what? Mass into gravitational acceleration, which is equal to W is equal to M into G. So this the mass, it is same everywhere. If it is 60, so its value is 60 on Earth. If we shifted the same material to the Earth, sorry, to the moon, so it would be same 60. But the gravitational, as we see, the gravitational on Earth it is maximum 9.81. As we move up, down, up. So maybe to Moon it is reduced to 1.6. So it is in multiplication. If the multiple factor of the multiple value is bigger, so the answer will be bigger. If the multiple value is smaller, so the answer is smaller. So that's why mass, in simple, you can say mass is same everywhere. It doesn't depend upon the location or position, while the weights it's depend upon the gravitational forces, and the gravitational forces depend upon the position. If it is on Earth, so it is more. If it is on the Moon, so it is reduced. So this is the main difference between mass and weight. And there is one more thing: mass, its unit is usually used kg, and for the weight we use the unit usually what? Newton. So as you can see here, W is equal to m multiplied by g. What is the unit of mass? Kg. And what is the unit of gravitational acceleration? So it is mass meter per second square. So this is g. So this kg into meter per second square is called what? Newton, which is denoted by n. So the unit of weight is Newton and the unit of mass is kg. I think now it is clear. So the same information is given here, so you can read it by yourself. So I just explain the concept, what is the concept behind the mass and weight. Now we are going toward the next slide, in which they are discussing, there is one numerical example. Let's try it. So the value of, let me, okay, I would like to try solve this example on this white screen. So here you can see here is a man. His mass, sorry, mass of man is equal to how much? Sorry. So mass of person, let me try, what is the problem? Mass of person, any man on earth. So mass of person is given how much? It is given 60 kg. And the gravitational forces, or the gravity on moon, it is given how much? How much it is? 1.6 meter per second square. So sorry for, before solving any numerical problem, so you should to split into three ways. The first one is required data. It is called the required data. The things, the information which is given to you. These two information is given to you. Then, sorry, it is not required data. You can see it is given data. It is given data. The first thing. The second thing is what? Required are to find data. So what we will find? Weight of the same person we are on earth. So, okay, the first thing is what? Given data. It is mass is equal to how much? 60 kg. Gravitational on moon is equal to how much? 1.6 meter per second square. And what should we to find? Our required data. Weight of person, earth, and the weight of same person on. So the third step is know what? Solution. So first we are going to calculate it on earth. So as we know, W is equal to mass multiplied by G. So W is equal to how much mass is given, how much it is? 60. And on earth we already know what is the gravitation, it is 9.81. How much? Meter per second square, and this is 60 kg. So when 60 multiply 9.81, it is, I think so, it is 5588 point. 6. This kgs come here, multiply, this is meter per second here, meter per second square. So as we discussed in the previous, this kg into meter per second square is equal to how much? It is Newton. Now we are looking for the second one, which is what? Weight of person where on moon, the same person. W is equal to m multiplied by g. So as we know, the mass is everywhere same, so it is still 60 kg. But the gravitational forces is changed because, as we discussed in the previous, as we move up, the gravitational forces decreases. So it is decreased how much? 1.6 meter per second square. So now when we multiply 60 or multiply by 1.6, what is the value? Its value is come how much? I think it is 96. And what is kg into meter per second square? This kg into meter per second square is equal to how much? 96. It is Newton. So this is a short example through which I think you understand it. Okay, I'm trying to move a little bit fastly because maybe the videos become longer. So now there are three. What is the difference between density and unit weight? There are three general terms which describe the mass, weight, and volume relationships. What is density? In simple, you can say that. Let me clear it again from this. Let me explain here. Density. Sorry. Let me back to the screen. White. So it is what? Density. What is density? Density is mass per divided by unit volume. I will explain it more. So what is the unit of mass? Unit of mass is kg, and what is the unit of volume? It is meter cube. So now this is the unit of kg per meter cube is the unit of density. Density, it is denoted by a symbol sigma, mass by m and volume by v. So this is the formula for the density, and this is the unit of density. Now what does mean by density? For example, there is a box. Let me make it clear. Sorry for the diagrams. This is a box. For example, this is a length, height, and this one is the width. Okay, this is 1 meter, this is 1 meter, this is 1 meter, like cube. This all the three dimension are of same. All is 1 meter. So what is equal to volume? 1 meter multiplied by 1 meter multiplied by 1 meter. So the volume is equal to how much? 1 meter cube. So this is a cube of having the volume how much? 1 meter cube. Now if I fill this cube with water, so how can we define the density? That how much kg of water, that how much amount or how much quantity of water comes inside this 1 meter cube capacity. So this is called what? Density. Let me clarify. There is 1 meter cube box 1. This is 1 meter cube box 2. Okay, so I fill this cube with water and fill this one with the steel. The volume is same for both the cases, but the one A is filled with water and the another one is filled with the steel. So which one has more density? Obviously steel has more density because in 1 meter cubes here, most mass, more capacity or more masses or more wazn comes. So which has more weight, more mass? Steel has more mass. So if more mass comes, so it means it is more density. It is very clear. I will explain this concept here. Mass per unit volume, as we already know. So this is called nominator and this is called denominator in mathematics. In physics, it is called direct proportional, directly proportional, and this is called what? Inversely proportional. What does it mean? If the density, if the mass, direct, what does mean by direct relation? I will clarify it first. Direct relation means the first, if this quantity increases, the quantity or the amount, this one is also increases. If the mass is decreases, the density will be decreases. It is direct. If one is increased, the other one is decrease. The one is increased, the another one is increased. If the another one decrease, so the first one is also decrease. What is the inverse relation? Inverse relation means if this is increase, it will be decrease. If it is decrease, it will be increase. But in our case, you can see the volume is same for both. It is 1 meter cube, 1 meter cube. So it's mean we cannot differentiate the density on the basis of this because the volumes for both the element is same, but we can differentiate here the density with respect to mass. As we know, the mass of water is less as compared to the steel. So it's mean the steel has more mass. So if the mass is more, so it's mean the density is more. The steel, the water is less mass with compared to the water, so it has less mass. So this is the concept regarding what? Regarding the density. I think now it is clear for you guys. Also, one thing I intend the density of water, sorry, this is not density, this is density of water at 4 degrees centigrade. It is how much? 1000 kg per meter cube. So you should to remember this value. Now I'm trying to go back further. Another concept. Another one is what? Unit weight. So what is unit weight? Unit weight is where weight divided by unit volume. It is same, but like density. In density here we have what? Mass, and in unit weight we have what? Weight. So you already know what is the difference between watt and mass, weight and mass. Know what is weight? So the unit of weight is what? Newton or kilonewton. Unit of volume, meter cube. So its unit is usually used kilonewton per meter cube. So it is the same things if there is one box having volume 1 meter cube, this is the another box, so it is 1 meter cube, this is A, this is B, both have same volume, but it's depend upon the material, for example, water, and here it is again, I put it, for example, sand. So if I fill this 1 meter cube box with water, and the another one is 1 meter cube box is filled with the sand, so which has more weight? Obviously sand has more weight, so unit weight. This is the symbol which is used for unit weight. This is symbol of weight, symbol of volume. So if weight is more, the density unit weight is more. If weight is less, unit weight is less, and the volume is constant. You can say in both of it is same for the both. So here you can say the unit, the mass of sand is more. If the mass of sand is more, sorry, weight of sand is more, so it's mean the density is more. I think now you get this point. Okay, there is another, and also you should remember the gamma W unit weight of water. Unit weight of water is 9.81 kilonewton per meter cube. You should remember this value as well. If there is no kilo, as we know, kilo is equal to how much? 1000 or 10 power 3. So it means how much? You just multiply 9.81 multiply by 100. So it is come how much? Newton per meter cube. Okay, there is third property, sorry, which is specific gravity. It is denoted by GS. So it is the ratio of unit weight or density of given material to the unit weight of water or density at 4 degrees centigrade. So GS is equal to what? Unit weight of any material. Any materials means you can say sand, soil, gravel, any material, steel, with respect to the unit weight of water. Unit weight of water at how much? At 4 degrees centigrade. This is the standard, the temperature, as you already know, because if the temperature is 100, so that's how much the water is evaporated. If it is 0, so it is freeze. So this is the standard temperature at which the waters behave like fully liquid. So this is the ratio between what? The unit weight or density. You can also say density of any material divided by density of water. So why we are doing this? In this, we can compare the weight or density of any material the density of any material with respect to water. How much this material is, like if I take the cotton, so the cotton weight is less. So as we know, their value will become how much? 0.5. So what does mean 0.5? Shows that the cotton has 0.5 times less density than the water if the GS values come 2. So it means, like I am find for the sand, and this is the density of water. So already we know that sand is heavier. So what does these two shows? These two shows, or these two represent that the sand is 2 times heavier, or the density of sand is 2 times heavier than the water. So specific gravity, it is nothing, it is just the ratio which compare any material with respect to water. And you can see here the GS range from soil is 2.6 to 2.9. What does it mean by 2.6? 2.6 means that the soil of this density is like 2.6 means the soil, this type of soil is 2.6 times heavier than the water. What will be the GS of water? So it should be 1 because density of water with respect to density of water. So both are same, so it should be 1. Both are the same density. And one more important thing, specific gravity has no unit. Why? Because it is the ratio between same thing, same properties. Unit weight of anything, unit weight of water. This is unit weight, this is unit weight. For example, it is how much? Kilonewton per meter cube, and this is also kilonewton per meter cube. They cancel with each other. If you see density of any material divided by density of water, so how much kg per meter cube density? This is also kg per meter cube density. Both are cancelled. So it is very important if it's come in the exam or any interviews that specific gravity has no unit. Okay, guys, there are some relationship between density and unit weight. Sorry. So as we know, unit weight is equal to how much weight per unit volume. And also we know weight is equal to how much? Weight is equal to mass into gravity divided by volume. And there is one thing more, we also know that mass divided by volume per unit volume is called what? Density. So can I write here density multiply its own self, and G is here. So this is the relation between what? Unit weight and gravity density. This is the first one. Also for the GS, you can see here GS is equal to what? Density of soil divided by density of water. No, we already know density is equal to how much? Rho into G. So I can write density of soil multiplied by G, density of water multiplied by G. So this G cancel with this G. So what's remain? Density of soil divided by density of water. There is one thing more. So as we know, density of soil, can I write this equation? Density is how much? Mass of soil divided by volume of soil. Okay, this is density. Then divide by, this is density of water. So I split this density into mass per volume. It is like this, m divided by v divided by density of water. So now I shift this density here. This is mathematical rule. If this is like v divided by c, it is in division. If I move it from here to here, so it will come in multiplication. So it will become how much? Mass divided by volume multiplied by density of water. So it is the third equation. Now, this is very important topic, which is called soil phases system or soil phases diagrams. Soil, as they exist in nature, consist of solid particle, consist of what? Solid particle, sorry, solid particle, mineral grains, rock fragment, also water and air in the voids. So you can see this is the pinch of soil, or there is some amount of soil is present. So this is the soil particle which is in the form of solid, there is a gap between the particle. See this particle one, two, three, and there is the gap between the particle. It is called what? Voids. What? Voids. This gap is called what? Voids. So now these gaps, it may be filled with water or may be filled with what? With air. So it is possible, or maybe it is filled completely with water, or maybe filled completely with air. These all the possibilities happen. So there are three things: solid, liquid, liquid in the form of what? Water, and gas, which is in the form of air. So soil is mostly consist of these three states. So now you can see this. This is the soil particle. This is a solid. So this is the gap between two particles. It is called what? Void. So this void is maybe filled with air or water. I will try to explain this it very clearly. There is one thing, this is particle, so particle 1, this is particle 2, these are the particles. So the gap between two particles, it is called what? Voids. If there is any gap or any gap inside the particle, like there is a gravel and there is voids, if there is a stone in which there is a gap, so this is called what? Pores. If the gap is inside the material or inside the gravel or inside the particle, it is called what? Pore. The gap between two particles, this is one, this is two, this is three, so now they produce here gap. So this gap is called what? Voids. Now, as we discussed that there are three phase diagram. So in each soil may be present of what? Soil, maybe water, and maybe here. So it is called what? Three phase diagram. So now we can discuss it very clearly. If in the water, if in the soil, the solid particle is present, also there is white. So the white one, it means there is nothing, there is hawa. And the green, sorry, the blue one shows what? There is water. So the white is what? Air, the green is what? Water, and the brown, it is solid. So the soil in which these all three phases or three phases is present, solid, water, and air, so it is called what? Three phase diagram. And the soil is called what? Partially saturated soil. Partially means like 50-40% in a ratio base, like 10% maybe water and 90% maybe air, or maybe 50% water, 50% air, 60% water, 40% air. And water both are present, but we don't know here how much air percentage, but both are present. So in the soil in which all these three phases are present is called what? Partially saturated. Partially, as I discussed, saturated, when you hear the word saturated, so it is related with water, so it's mean it is water. So it is partially, some water is present in the void, some air is present in the void, and solid is here, so it is called what? Partially saturated. No, this is voids. If all the voids, it is filled with air, so it is called what? Dry soil. As it is very clear from its name, there is no water, it is completely filled with air. So all the void is filled with what? Air, so it is called what? Dry soil. The fourth one is when all the voids between the particle, it is filled with water, so it is called what? Fully, means completely saturated, means again water, soil, so it is called fully saturated soil. So here you can say also partially saturated mean in which both Hawa and water is present. Fully saturated means no air, just water, and perfectly or fully dry means no water, just Hawa, air. Now I would like to discuss this graph. So you can see this is the air, water, and solid. Which is what? This is a partially saturated soil. So now, as we know, there is volume and weight. We already discussed their relations and what is volume, what is mass, what is weight. So now this is what? Air. In this side, we are discussing about the mass and weight and mass, and the left side we are going to discuss volume, right? Mass and mass. As you know, Mass of air. Does air is any weight? No. Hawa is no weight. Water does have any weight? Yes. Mass of weight. Does solid is any weight? Yes. It is a weight, so we can write it ms. Does Hawa has volume? Yes. Hawa can occupy a space, so it has volume. Like for example, there is a balloon. When you when you when you are trying to how can I say inhale the air inside by mean of compressor or by mean of your mouth, so you are giving what hawa inside, so the balloon size is increases. So what does it mean? It has volume, so its volume is increased. So now you can say how much their volume. Their same water has volume, and same we can say solid is also volume. And also we can say weight of volume, volume of air plus volume of weight. This both is called what voids, because the water and air, they are present here in the voids. So to collectively to both this we can say what volume of void as well. So this is the whole diagram. You can say mass here. You can say volume, volume of voids, volume of water. So this is total volume. So how can we calculate total volume? This is volume of air plus volume of water plus volume of solid. Also, we can calculate volume of air plus volume of water is also called what? Volume of voids plus this is volume of solid. Mass, total mass, how can calculate mass of air plus mass of water plus mass of solid. So as we know, Hawa is no mass, air is no mass, so total mass equal to how much? Mass of water plus mass of solid.